There's a building somewhere in the world where millions of bananas disappear every single day. Not into grocery stores, not into fruit stands, but into something far more complex. Inside these walls, yellow crescents transform into golden chips, sweet cakes, and shelf-stable snacks that travel thousands of miles without spoiling. Most people have eaten these products dozens of times without ever questioning how a fruit that browns within hours can last for months in a sealed bag. The answer lies behind the heavy steel doors of industrial banana processing facilities, where ancient preservation techniques meet cutting-edge automation. What you're about to discover isn't just about food. It's about the hidden engineering that turns one of the world's most perishable crops into one of its most profitable snack foods. The banana processing industry operates on a scale that defies imagination. Walk into one of these facilities during peak season, and you'll witness conveyor systems stretching the length of football fields, carrying endless rivers of green fruit toward their transformation. The air smells sweet, almost intoxicating, a mixture of ripening sugars and the faint chemical tang of preservation solutions. Workers in white coats and hairnets move with choreographed precision, their movements synchronized with machines that never stop, never sleep, never waste a single piece of fruit. This is where food science becomes industrial art, where the simple banana reveals secrets that took decades of research to unlock. The global banana processing market generates over $8 billion annually, yet most consumers have never seen inside these factories. They remain invisible, tucked away in tropical regions where bananas grow abundantly and labor costs make large-scale processing economically viable. Ecuador, the Philippines, Costa Rica. These nations house some of the world's most sophisticated banana processing operations, facilities capable of converting 40 tons of fresh fruit per hour into finished products. But the real mystery isn't the volume, it's the precision. How do you take a fruit with such a narrow window of perfect ripeness and process it consistently, day after day, maintaining identical taste, texture, and color across millions of packages? The answer begins long before the bananas arrive at the factory. It starts in the fields, where harvesting teams use color charts and firmness gauges to select fruit at exactly the right stage of maturity. Too ripe, and the bananas turn to mush during processing. Too green, and they lack the sugar content needed for proper flavor development. This selection process represents the first critical control point in a chain of precision that extends all the way to the sealed package on the store shelf. Every banana entering a processing facility has been evaluated, graded, and approved based on criteria most people never consider: curvature, length, diameter, blemish count, and something called the pulp-to-peel ratio, which determines how much usable fruit each banana contains. One of the most fascinating aspects of banana processing involves the chemistry of browning prevention. Cut a banana and leave it exposed to air, and within minutes, enzymatic reactions begin turning the flesh brown. This oxidation process, triggered by an enzyme called polyphenol oxidase, represents the primary challenge in banana processing. Manufacturers have developed multiple strategies to combat it: acidic solutions that lower pH and slow enzyme activity, sulfite treatments that chemically block oxidation, vacuum processing that removes oxygen from the environment, and rapid dehydration that removes the water needed for enzymatic reactions to proceed. Each method has advantages and disadvantages, and the choice depends on the final product being manufactured. The banana chip production line represents perhaps the most visually striking process in these facilities. Imagine a continuous ribbon of precisely sliced banana rounds, each exactly 2.5 millimeters thick, moving through a series of treatment baths before entering massive fryers filled with bubbling oil. The slicing machines use rotating blade drums that can process up to 2,000 pounds of bananas per hour, each fruit automatically oriented and positioned for optimal cutting. The precision is remarkable. Variations in slice thickness of even half a millimeter result in uneven cooking, with some chips burning while others remain soggy. Computer vision systems now monitor slice thickness in real time, automatically adjusting blade pressure to maintain consistency. Before frying, the banana slices pass through a solution bath, typically containing citric acid, ascorbic acid, or sodium metabisulfite. This treatment serves multiple purposes: preventing browning, enhancing flavor, and creating a slight acidity that balances the sweetness of the finished chip. The concentration of these solutions is carefully controlled, monitored hourly by laboratory technicians who test pH levels and chemical concentrations. Too weak, and the chips brown during storage. Too strong, and they develop an unpleasant chemical taste. The frying process itself is a masterpiece of thermal engineering. Industrial banana chip fryers maintain oil temperatures between 320 and 350 degrees Fahrenheit, hot enough to rapidly dehydrate the fruit while creating the characteristic crispy texture consumers expect. The bananas spend approximately 3 to 4 minutes in the oil, during which their moisture content drops from about 75% to less than 3%. This dramatic water loss causes the cellular structure to collapse and crisp, transforming soft fruit into crunchy snacks. Modern systems use multi-zone heating, with slightly cooler oil at the entrance to prevent surface burning and hotter oil at the exit to ensure complete moisture removal. Please subscribe to our channel and hit the like button to support more behind-the-scenes content like this. After frying, the chips move through cooling tunnels where ambient air brings them to room temperature while excess oil drains away. This cooling phase is critical. Package hot chips, and condensation forms inside the bag, turning crispy snacks soggy within hours. The cooling conveyors are designed with perforated belts that allow air circulation from below while preventing chips from falling through. The target final oil content for most banana chips ranges between 25% and 35% by weight, significantly lower than potato chips, which often contain 35% to 40% oil. Seasoning application happens in rotating drums that tumble the chips while spraying them with flavoring solutions or dusting them with powdered seasonings. The challenge here is achieving even coating without breaking the delicate chips. Salt, sugar, cinnamon, chili powder, honey coating. The variety of flavors has expanded dramatically in recent years as manufacturers seek to differentiate their products in competitive markets. Some facilities produce over 50 different flavor variants, requiring complex scheduling and thorough cleaning between production runs to prevent flavor cross-contamination. Quality control in banana chip production involves both automated and human inspection. Optical sorting machines use high-speed cameras and artificial intelligence to identify and remove defective chips, those that are too dark, too light, broken, or contaminated with foreign material. These systems can inspect thousands of chips per minute, far faster than human inspectors, while maintaining consistent standards. However, human sensory evaluation remains irreplaceable for assessing flavor, texture, and overall quality. The production of banana cakes and baked goods follows a completely different process path, one that begins with banana puree rather than fresh fruit. Creating consistent puree requires precise control over ripeness, as the sugar content and flavor profile change dramatically as bananas mature. Manufacturers typically use fruit at the full yellow with brown spots stage, when sugar content peaks and the characteristic banana flavor is most pronounced. The bananas are peeled, either manually or using mechanical peeling systems that use compressed air to literally blow the fruit out of its skin, then mashed into smooth puree using industrial blenders or pulping machines. In the cake production area, industrial mixers combine banana puree with flour, sugar, eggs, oil, and leavening agents in precisely measured proportions. These aren't the stand mixers you see in home kitchens. They're massive planetary mixers with 500-liter capacities, capable of preparing enough batter for thousands of cakes in a single batch. The mixing process follows a specific sequence. Dry ingredients are combined first to ensure even distribution of leavening agents. Then wet ingredients are added gradually while mixing at controlled speeds. Overmixing develops too much gluten, creating tough, rubbery cakes. Undermixing leaves flour pockets and uneven texture. Depositing the batter into pans happens via automated systems that ensure consistent portion sizes. Imagine a row of cake pans moving along a conveyor beneath filling nozzles that dispense exactly the same amount of batter into each pan, controlled by volumetric pumps or weight-based systems. This consistency is crucial. Overfilled pans overflow during baking, while underfilled pans produce cakes that are too flat and dry. The baking ovens in industrial banana cake facilities are engineering marvels. often stretching 40 to 60 feet in length with multiple temperature zones. The cakes enter at one end and emerge fully baked at the other, typically after 25 to 35 minutes of precisely controlled heating. Modern ovens use both radiant heat from heating elements and convection from circulating fans to ensure even baking. The temperature profile isn't constant. Cakes typically start at lower temperatures to allow even rising, then finish at higher temperatures to set the structure and develop the golden brown crust. As the cakes bake, the Maillard reaction occurs, a complex series of chemical reactions between amino acids and reducing sugars that creates the characteristic flavor and color of baked goods. This same reaction happens when you toast bread or sear a steak. It's fundamental to much of what makes cooked food delicious. In banana cakes, the Maillard reaction combines with the fruit's natural flavor compounds to create the distinctive taste that consumers recognize. After baking, the cakes must cool before packaging. Cool them too quickly, and thermal shock can cause cracking or collapse. Cool them too slowly, and condensation forms, promoting mold growth. Most facilities use multi-stage cooling. First, a period at room temperature to allow the internal structure to set, then forced air cooling to bring the product to packaging temperature. Now let's explore the fascinating journey of raw materials and the complete manufacturing process that transforms simple bananas into these diverse products. The process begins in the tropical plantations where bananas grow in massive bunches, each containing 50 to 150 individual fruits. Harvesting happens year-round in equatorial regions, with workers using long poles with curved blades to cut down entire bunches when the fruit reaches the three-quarter full stage, still green but physiologically mature. This timing is critical. Harvest too early, and the bananas never develop proper flavor. Harvest too late, and they ripen before reaching the processing facility. Upon arrival at the processing facility, the banana bunches undergo initial inspection and washing. The washing system uses multiple stages. First, a dry brushing to remove field debris and insects, then a water bath with mild detergent to remove dirt and pesticide residues, followed by a sanitizing rinse with chlorinated water to reduce microbial load. The water in these washing systems is continuously filtered and treated, with fresh water added to compensate for losses while maintaining proper chemical concentrations. After washing, the bunches move to dehanding stations where workers or machines separate them into smaller clusters called hands, each containing 10 to 20 bananas. This separation is necessary because bananas in different positions on the original bunch ripen at different rates, and processing requires uniform ripeness. The hands are sorted by size and ripeness stage, with each category directed to appropriate storage or processing areas. For products requiring ripe bananas, the sorted hands enter ripening rooms, sealed chambers where temperature, humidity, and ethylene gas concentration are precisely controlled. The ripening process typically takes 4 to 7 days, with the fruit progressing from hard and green through various stages to the desired level of ripeness. By manipulating ethylene concentration, temperature, and humidity, technicians can program bananas to reach perfect processing ripeness on exactly the day they need it. When the bananas reach processing ripeness, they move to the production floor, where different product lines diverge. For dried banana chip production, the fruit first passes through peeling stations. Manual peeling remains common in many facilities, as bananas are regular shapes and varying peel thickness challenge mechanical systems. However, advanced facilities now use pneumatic peeling machines that inject compressed air between the peel and fruit, literally popping the banana out of its skin. These machines can process up to 1,200 bananas per hour per unit, dramatically reducing labor costs. The peeled bananas are immediately immersed in holding tanks containing acidulated water, typically with citric acid or ascorbic acid added to prevent browning. From these tanks, they're fed into slicing machines, precision instruments with circular blades rotating at high speed. The bananas are positioned by mechanical guides that ensure consistent orientation, then pushed through the blade at controlled speed. The resulting slices fall onto conveyor belts that carry them through the anti-browning treatment bath. The frying system represents one of the most expensive and critical components of the production line. Modern continuous fryers are essentially long, enclosed vessels filled with cooking oil, with conveyor systems that submerge the banana slices and carry them through at controlled speed. The oil is heated by gas burners or electric elements, with temperature sensors throughout the fryer providing feedback to control systems that maintain precise heat levels. Sophisticated filtration systems continuously remove particles and degradation products, extending oil life and maintaining consistent frying performance. Emerging from the fryer, the chips are extremely hot and fragile. They travel through a de-oiling section where vibrating screens and air knives remove excess surface oil, then enter cooling tunnels. The cooling process is carefully controlled. Too rapid, and thermal shock can cause cracking. Too slow, and the chips may not be cool enough for packaging, leading to condensation problems. For banana cake production, the process diverges significantly after the ripening stage. Ripe bananas are peeled and fed into industrial pulping machines, which use rotating blades or crushing rollers to break down the fruit into smooth puree. The pulping process must be thorough enough to eliminate lumps but gentle enough to avoid excessive aeration, which can lead to oxidation and off flavors. The banana puree is immediately combined with other ingredients in the mixing area. Industrial bakeries use automated ingredient handling systems that store dry ingredients in silos and liquid ingredients in tanks, with computer-controlled dispensing that measures exact quantities for each batch. The mixing process follows a precise sequence programmed into the mixer's control system. The mixed batter is pumped to depositing stations where it's portioned into baking pans. Modern depositing systems use servo-controlled pumps that can adjust portion size on the fly, allowing rapid changeover between different product sizes. The filled pans are automatically loaded onto racks or conveyor systems that carry them into the ovens. The tunnel ovens used in industrial banana cake production are marvels of thermal engineering. They're divided into multiple zones, each with independent temperature control, allowing precise heat profiles tailored to specific products. The cakes typically spend 25 to 35 minutes in the oven, traveling through zones that might range from 300 degrees Fahrenheit at entry to 350 degrees at the center and back to 320 degrees at exit. Emerging from the oven, the cakes are extremely fragile and must be handled carefully. They're typically left in their pans for an initial cooling period, allowing the structure to firm up before depanning. Automated depanning systems use gentle vacuum suction or mechanical fingers to lift cakes from pans without damage. The empty pans are immediately washed, sanitized, and returned to the filling station. For products that receive glazing, the cooled cakes pass under curtain glazers, machines that create a continuous waterfall of glaze through which the cakes travel. The glaze is maintained at precise temperature and viscosity, with continuous stirring and temperature control to ensure consistent coating. After glazing, the cakes pass through drying tunnels where controlled airflow sets the glaze into a protective coating. Quality control throughout the process involves multiple checkpoints. Raw material inspection ensures incoming bananas meet specifications for size, ripeness, and quality. In-process monitoring checks slice thickness, frying temperature and time, batter consistency, baking temperature profiles, and cooling rates. Finished product testing evaluates appearance, texture, flavor, moisture content, and microbial safety. Packaging represents the final critical step in preserving product quality. For banana chips, packaging must provide an effective barrier against moisture and oxygen, the primary enemies of crispness. Most chips are packaged in metallized polymer films that combine excellent barrier properties with heat sealability. The packaging process typically occurs in a modified atmosphere, with nitrogen gas flushing out oxygen before the package is sealed. Banana cakes are often packaged in flexible film pouches or rigid containers, depending on the product format and market requirements. The packaging must prevent moisture loss, which would dry out the cake, while also blocking moisture gain, which could promote mold growth. Many cake packages include oxygen absorbers, small sachets containing iron powder that chemically binds oxygen. The packaged products are labeled with production dates, best by dates, nutritional information, and ingredient lists, then packed into shipping cases. These cases are palletized and moved to warehouse storage, where they await distribution to retailers. The entire journey from fresh banana to packaged snack typically takes less than 24 hours for chips and 48 hours for cakes. Throughout the facility, automation and human expertise work in tandem. Machines handle the repetitive, physically demanding tasks: conveying, slicing, frying, baking, packaging. Humans provide judgment, troubleshooting, quality assessment, and process optimization. The most advanced facilities use industrial IoT systems that collect data from hundreds of sensors throughout the production line, feeding it to central control systems that optimize operations in real time. Food safety. Workers follow strict hygiene protocols: hand washing, protective clothing, no jewelry, health monitoring. Water usage in banana processing is substantial, with washing, blanching, cooling, and cleaning all requiring large volumes. Modern facilities increasingly incorporate water recycling systems that treat and reuse water multiple times before discharge. Energy efficiency is also a major focus, with heat recovery systems capturing waste heat from ovens and fryers to preheat incoming water or air, reducing overall energy consumption. The banana processing industry continues to evolve with changing consumer preferences and technological advances. There's growing demand for organic products, which require separate production lines and rigorous documentation to maintain organic certification. Clean label products with minimal ingredients and no artificial additives are increasingly popular, challenging manufacturers to achieve shelf stability through processing techniques rather than chemical preservatives. Behind every bag of banana chips and every packaged banana cake lies this intricate web of agriculture, chemistry, engineering, and logistics. The next time you open a package of dried banana snacks, you'll know the hidden world that made them possible: the ripening rooms with their precisely controlled atmospheres, the slicing machines with their micrometer precision, the massive fryers with their multi-zone heating, the quality control laboratories with their rigorous testing protocols. It's a world where ancient preservation techniques meet modern automation, where simple fruit becomes shelf-stable snacks through processes that took decades to perfect. Word count check. This script contains approximately 3,250 words. We've just scratched the surface of industrial food processing, and there's so much more to explore. Speaking of fascinating transformations, have you ever wondered what happens inside a cane sugar factory? How does sugarcane transform from a tall grass into the white crystals that sweeten everything from your morning coffee to those banana cakes we just discussed? The video that just appeared on your screen takes you inside that world, a journey through crushing mills, clarification tanks, crystallization chambers, and centrifuges operating at forces that would make a fighter pilot dizzy. Before you click over, do me two quick favors. First, hit that subscribe button and turn on notifications so you never miss these deep dives into the industrial processes that shape our daily lives. Second, drop a comment below. What surprised you most about banana processing? Was it the precision of the slicing machines? The multi-zone frying technology? Or maybe the fact that a single facility can process 40 tons of bananas per hour? Your comments help shape future videos, and I read every single one. The world of industrial manufacturing is filled with hidden marvels, processes operating at scales and precision levels most people never imagine. This channel is your backstage pass to that world. See you in the next one.